the interesting where it kind of comes from some of the similarity stuff, and then some of the later triangles too. But today we just want to be able to distinguish between congruent and similar triangles, and then solve word problems involving similar triangles. Okay. So we're just gonna have a look here. Okay. So congruent triangles basically mean that the two triangles are going to be identical. Okay. All corresponding angles and sides are equal, and they're the same shape and size. Okay. And then this is your expression that denotes congruency. Okay. Specifically, this little like funny sign in the middle, that's denoting congruency. Okay, so here's what I want to do here. Okay, this little statement here is based off of, we're going to say this triangle. Okay, so these series of triangles. Okay, so what I'm going to do here, I'm just going to redraw this picture with both triangles kind of side by side, but not like flipped like the way it is. It might be better to freehand it. Okay, so we're going to have A down here in the corner, and then B up top, and C. Okay, and then I'm going to redraw this one here. Okay, and I think this is where people kind of like get a little bit not confused, but just the way that they label things gets messed up because they haven't redrawn the triangles side by side. And so if I were to redraw this triangle here, it'd be something like this. That's supposed to be identical too, by the way, in size. F, E, and D. Okay, and then so what you're going to do is you want to like make a statement or come up with what side lengths or what point or angles, not points, but what angles go with what angles and what side lengths go with what side lengths, right? That's kind of what we're trying to do. So we're going to say A, or angle A, has to go with angle F. Okay. These can get a little more difficult from the standpoint that they're not as easy to line up when drawn like this. Okay. And so you just try and make it a habit of drawing these in a way that you can clearly see what goes with what side by side. Okay. Next one I'd say would be like B goes with E, right? And then by default, C goes with D. Okay, does anybody have any questions? Okay, they've also drawn some other things on here, like this hash marky kind of thing, the AC. Okay, that's saying that like they're just trying to mark that these two things are equal. Okay, equal, but also different from the rest of the triangle. So if you look at AB, AB only has one hash mark, right? And FE has one hash mark. Okay, but so they're different from this side length, right? But the same across triangles. Okay, that's how they're like marking it. And the last one they've used the squiggly to represent this side length being the same as that one. Okay, and so we want to make a statement or a few statements down here, right? The first one is to prove congruency, like the angles should all be the same. And so what we're going to say down here is angle A is equal to angle F, angle B is equal to angle E, and angle C is equal to angle D. Okay, that takes care of the first one where we're checking the angles are all the same. Okay, the other one, and kind of the point today, not the point today, one of the things that we're going to see come up, and we just want to cover our bases from the standpoint that like you know what I'm talking about when we do this, is how to write a particular side length on a triangle. Okay, so if I'm looking at the side length that's created here, right, that's side length AB, right? We go from A to B or BA. Okay, it just depends. It doesn't really matter too much, but to denote a side length, kind of like drawing the little bar on top too. Okay, and then to check or prove that something is congruent, AB must equal FE. Okay, those two side lengths are equal. And then there, we have to say that AC, or you could do BC, has to equal ED, right? That would be these two side lengths. Okay, and don't forget your little bars on top, okay? And then CA is equal to DF. Does anybody have any questions? That's what it means to be congruent. They're like virtually identical, and you're just checking to see that all the angles match and all the side lengths match. Okay, that's for congruency. Okay, and here's some more down here. He just kind of like puts them into rules. All sides are equal. Okay. If you weren't provided all three side lengths or whatever reason, they're giving you different scenarios down here where you're provided different kinds of information. Okay. Okay. So congruency means the exact same. That's kind of the gist there. Okay, which the only thing I can really ask you is, are these two triangles congruent, right? Because what am I going to ask you? This triangle is congruent to this one. What's the side length? What's the same? There's nothing really interesting going on there, right? Anybody have any questions? Okay, so let's just come down here. We're just going to try this one question, okay? And we're going to say, okay, we just got to prove that these two things are congruent, okay? You could, if you'd like, this helps me sometimes, like when I don't redraw these things sometimes, I can flip, especially when they get a little more complicated, I start messing up the side lengths, okay? So I'd say, okay, well, if I were to redraw this thing just immediately underneath, you could see that we're going to get F over here in the corner, E up top, and G down here in the corner, in the bottom. Okay, and then you can say, okay, side length, I'm going to forget this is here. I can say, okay, NM is equal to EF. FG has to equal, oh sorry, other way around here. ML has to equal FG. Okay. Now, here's a catch. If these two match, so you can see here, actually I forgot to draw something in the new picture. There's a little 90 degrees sitting in here too, right? That's what that means, which we're going to spend actually a ton of time dealing with. So you have to know that the little square in the corner means 90 degrees. Okay. Okay. And so the other thing you have here is you have an angle that matches between the two triangles as well. And so if we look at which condition that we've used here, right? If you look at angle M is equal to angle F, it's contained between these two side lengths, right? You can see it. Right? It's the angle that's created by those two side lengths in both these triangles. And so we've used the second condition for congruency by showing that we have two side lengths that is the same, right? And also what we call this contained angle in the middle. Okay? You could also find that if we had another triangle down here, you could see that maybe you have two angles that are the same and one side length. That would be congruent as well. Okay? Does everybody have questions? Again, not a whole lot I can ask you with this aside from, are these two triangles congruent? Okay? Now, we need to make the pivot to, well, if something's not the exact same triangle, right, which in most cases is not going to be true, right, then we need to like figure out a way to work with like situations that isn't true, right? So that's where the similarity piece comes in, right? Where the two triangles are going to be similar, but not the same. Okay, so there's a little bit of work that we can do there. Okay, and so it doesn't, and this relates to a lot of things just outside. Like it doesn't have to be triangles either. It could be any shape, really, right? But for triangles, we're going to say similar triangles have the same shape but a different size, right? So one triangle is an enlargement or reduction of the other, but all the corresponding side lengths are proportional, okay? The word proportional means that they're changing in the same way, all of them, okay? But, and here's the important one. Oops. All the angles are equal, okay? And so the expression, this is how we denote similarity, right? You'll notice we're missing the equal sign, okay? This is how we denote similarity between triangles, okay? So if we come down here, we can see the x should be up top. This x should be up here. Okay. If we look at this, we could see, okay, they look like the same shape, right? They're both triangles, right? But we want to know, okay, well, what's similar and what isn't? Okay, well, all the angles are going to be the same, right? It looks like they've denoted that, right? And I just moved the x. I think the x was in the wrong spot, okay? So we're going to say, okay, well, we're trying to prove whether or not the angles are the same. Well, angle A equals angle E. Angle B equals angle F. Okay? And if we know that two of the angles are the same, right, all three angles have to add up to, and maybe you guys have seen this before, I don't know. All three angles, like let's say angle A plus angle B plus angle C, all have to equal 180 degrees in a triangle. Okay, so the same must be true for like any triangle, right? And so angle E plus angle F plus angle D also has to equal 180 degrees. Okay, well, if we've said that these two are the same, we've said these two are the same, and these two are the same, then the only way that this statement can be true is if these two are also the same. Okay, so that must mean that angle D has to equal angle C has to equal angle D. Okay? And then on the side here we have the conditions for similarity. Okay? So there's three methods to prove whether or not these two things or two triangles are similar. Okay? Three pairs of corresponding sides are proportional. Okay, so we're going to get into what this actually means, this proportional piece. Okay, and the triangles are similar. If two pairs of a corresponding sides are proportional and the contained angles are equal, then the triangles are similar. Okay, so that's like much like earlier. You're going to have a side length meeting a side length, and then this is what they're calling this contained angle. Okay, that's number 2. Okay, number 3 is what we just finished talking about up here. Okay, if you have 2 of the same angle, then the thirds must match as well. Okay, 2 pairs, then you have a third pair that matches as well, because they have to all add to 180. Okay, those are your 3 conditions. I don't like this arrow, it looks weird. Okay, does anybody have any questions? So far, this has just been a lot of like, I don't know, it's kind of nitty gritties of this. Like once you get into actual practicality, it's not too bad. Okay, it's just, this is a lot of wordy math. Okay, and when we do the problems aren't actually that bad. Okay, so prove that the following triangles are similar is what we want to do here. Okay, so it looks like we've got matching angles. We have 2 matching angles in there, right? Which must mean, and by that I mean we're looking at, okay, well, we've got 1 angle there and 1 angle there that match. Okay, it also looks like, just by the way that they've denoted the triangles, that this angle matches this one. Okay, well, this meets the third condition for similarity, because I have 2 angles that match. And then therefore the third, these ones must also match, right? Just by default for this rule up here, right? From a reasoning perspective. Okay, so now we have to figure out, okay, well, how are they similar? Like, how are the 2 triangles changing from one to the other? Okay, you're gonna say, okay, well, you're just matching up the side lengths. Okay, well, it looks like we're gonna have 3 side lengths here, right? This is what we're gonna do. I'm gonna write this down here. Okay, you're gonna have ME. This is what we're gonna call like a proportion statement. Okay, ME would be over, or side length ME would be over side length JR, right? Which would equal, if these are truly proportional, which would be side length EP over RS over MP Okay, all I've done is, and I'll highlight these so you guys can see them. Okay, all I've done is I've looked for which side lengths are similar and I've written them over top of one another. Okay, so for instance, I'm just looking at ME is this side length right here, ME, I put right there. That was similar to, or should be similar to, or proportional in some way, to side length JR, which I wrote here. Okay, and then I wrote, okay, well, EP goes here, right? I said that was going to be similar to, just based on the way that I've orientated the triangles, right? RS. Okay, and the last one that I did would have been, I don't want to use blue, use black. MP went with JS, okay? So what I guess I'm trying to do here is illustrate to you that yellow goes with the yellow, the red goes with the red, and the black goes with the black, okay? And you can see that if these two triangles are similar, right, I should get something in common across those, all of those, right? The thing in common is going to be what I'm going to do now, okay? So what you can say is, okay, well, I know what the yellow pieces are, so why don't I just plug them in and see what I get, right? So for instance, I could take the numbers and plug them into their corresponding spots, right? So I could say, okay, well, ME is 4.5 and JR is 3. Okay, well, let's go EP now. Okay, well, EP is 9 and RS is 6. All right, well, let's write the next one. MP, we don't know. Okay, that's what it means by determine the unknowns, which we'll get to in a second, right? But we know JS, so we're gonna replace MP with the X that we're trying to find, and JS is 13. Okay, so we're still in the first part here. Okay, we're not going to deal with the X value yet, but I can use in the first part. That's what we're going to try and answer. Prove whether or not the following triangles are similar. Okay, well, how do I do that? Right. Well, if you remember, there should be something common across both those triangles. Okay. It doesn't look like there is right now, right? But if you go back up to what we defined similarity to be, the very first thing we defined was have the same shape but different size. So the question you're trying to answer for yourself is, are these two triangles the same thing, just that one's a smaller version than the other, is what you're trying to figure out. Okay, well, if, for instance, the answer is sitting right there in this line, okay, as to whether or not these two triangles are what we call similar. Okay, what you can do, I'm just going to pull up my calculator here, if I can find it. Okay, what you can do is you can type in what 4.5 divided by 3 is. It's 1.5. Okay, well, 1.5, right, is equal to, we're checking whether or not this is a true statement. So I better see the fact that 6 divided by 9, or 9 divided by 6, is 1.5 also. Look at that. So it looks like these two side lengths, 4.5 to 3, that's changing by a factor of 1.5, right? In either direction. It looks like it's shrinking from this direction to this one. Okay, we'll deal with that once we actually start answering questions here. But it also looks like this side length here, the two red ones, are also changing by the same amount. That's what we define by similarity, right? So if I go through here and I say, okay, if these two colored pieces match, then the triangles are similar. Okay? If they don't match, then they can't be similar, right? There's just nothing common across them. They're two triangles that maybe look like they're similar, but their values don't confirm that they are similar. Okay? So it's making the two pieces, the two colors match, right? If they match, they're similar triangles. Okay? Now, there's one other piece here. And it's, can we determine the unknowns, is what we ultimately want to be able to do here. Okay? And so you're going to go, okay, well, this is also equal to x over 13. So how would I find x in this scenario, right, is the question. Well, 1.5 equals 1.5. That's like, those two things are equal. So you're able to go 1.5, right? They're the same thing. So you're just going to write 1.5. And that's equal to x over 13. How would you ever find x in this scenario, is the question, right? Well, you're like, okay, well, why can't I just like multiply both sides by 13? Right? You can say, okay, well, let's do that. Multiply both sides by 13, I'm going to get 13 multiplied by 1.5. That's equal to x. I now have x by itself, right? So I multiply by 13 on both sides. The 13s cancel, right? And so if you just do the math on that, 13 times 1.5, 19.5. you now know, using similar triangles, what this value is over here. Okay, does anybody have any questions? I don't necessarily expect you to write this out every time. That's just the thought process, right? That's me connecting what we talked about up top and then relating the specific problem to that statement. Okay? What you'll see here in the next question, we'll do this next question with a little bit of a faster pace from the standpoint that I won't do as much formal mathematical writing, okay? But this is what's going on every time. I'm writing a series of proportional statements, right? Okay, and if you see that these things are changing by the same amount, then you know the two triangles are similar, right? Because they're this side length over here. I'm going to use a different color here. This triangle is specifically 1.5 times bigger than this one. That's what it means. Okay? So we can use that notion to solve other things. Okay? But it all comes out of like matching up side lengths, right? So if we go, I'm going to shrink this down here, save myself some space. Okay? I'm going to go over to C here, and I'm going to write, I'm just going to write this out. Okay? There's lots of stuff going on here, and this is maybe an example of where solving these questions gets a little bit tricky, right? Because there's just so much stuff and it looks kind of ugly. But if you were to write the two triangles separately, okay, that's what I'm going to do here. I'm going to have, I'll draw the big triangle first, right? ADE. That's what I'm going to draw first. Okay, let's draw ADE down here. ADE. Okay, and then you can write the information in there that you know is there, right? Well, okay, angle D is 75 degrees, and A they've denoted with the letter Z, and E is going to be Y. But then they've also said, okay, well, what's the side length here? Is what I need to know. What's AD? Well, it looks like AD is going to be 15 plus 5, so it's 20. Okay. And then I need to figure out, okay, well, what's this side length over here? Well, it's 18 plus X. Okay. And we don't know the bottom. Okay. So then I can go, okay, let's write ABC. Okay, as a little triangle beside. A, B, and C. Well, it looks like, okay, AB is going to be 5. They've said this is W, and this is 50. Okay? And then this is X. Okay? If I go back up here and just have a look at my rules, okay, we're just trying to prove whether or not this thing's going to be similar. Okay? That looks like I also have this down here. Just to make this a little bit bigger so we can see. Okay? I'm trying to prove whether or not these two things are similar, right? And ultimately, I think the goal of these questions is, like I could try and trick you by saying, okay, no, they're congruent, but you could find whether or not the two things are similar. I think I missed. Oh no, I'm okay. The goal is ultimately to figure out what this value of X is. okay, with these questions. Okay. And that's just, well, it also looks like I forgot to label an angle up here, Z. Okay. It looks like we've got two contained angles that are the same in this question. Okay. And that just comes from like some of your rules, right? And so if I have the two contained angles, then I can say there are two angles, corresponding angles that are equal, right? As per this one, then I can solve this in a proportional way, right? It's similar. So what you can say is, okay, well, side length AD has a value of 20, right? And I'm going to try and match that up with side length AB, which was 5, right? Okay, so let's make that statement then. 20 over 5 has to equal, this is a little bit harder of a question, right? You're going to see down here when we start doing some of the word problems, it's not so bad, right? So here's the catch here, though. This is going to be equal to 18 plus x over x, because these are the side lengths that I've matched up, right? You can see here, 18 plus x goes with the x side length here. Okay? And so here's what's going to happen. You're just going to solve for x here. This looks a little bit harder, but it's you have the skills to do this. You can figure out, okay, well, what's 20 divided by 5? That's going to be 4. So let's just do this in steps. Okay? Now, you can multiply both sides by x. Multiply by x. Okay, that little dot means multiply. Okay, so you're going to get 4x is equal to 18 plus x. All you're going to do is collect like terms and solve for x. So how do I do that? Well, I could subtract an x from both sides. That essentially moves this one to the other side, right? Just like normal. And you have 4x minus an x is equal to 18. 3x is equal to 18. X is equal to 6. Right? We've now determined what the unknown is. Okay? That's a little bit harder of a question, but I just wanted to show you that from the standpoint of like, it looks really hard, but then if you draw the two triangles, it's the exact same process as the question on the left. Okay? This gets a little bit trickier with maybe the solving, right? You're going to see that most of the time, especially with what we're doing, these kind of questions is all I'm asking you really to do. Okay? Does anybody have any questions there? Just looking in the chat, okay? So, I just want to run through a couple more just before we get, well, I guess we got 15 minutes. I just want to run through a couple of these and show you guys how to do this, okay? This is really the expectation of this chunk, okay? Can we solve problems involving similar triangles? Okay, the top half of this is just like math jargon, if you will, okay? It's just giving you the kind of background from a mathematical standpoint, and now we're actually just going to actually answer problems, okay? So, one thing we didn't talk about on the top is this notion of what the scale factor is. Okay, that's what we're just going to talk about that now. It's just, we did do it, we just didn't put that name on it. Okay, and you're going to see what it is. The scale factor just defines like how is the triangle changing specifically, like how much is it changing. Okay. Okay, we saw this in the other questions, right? So for instance, like this one was getting 4 times bigger or smaller, and this one was getting 1.5 times bigger or smaller. That's how this is changing. Okay. So you're going to apply your rules of similarity to these triangles, right? It looks like right off the top, I again have two contained angles that are the same, right? And they're shared across the triangles. it also looks like I have another one down here, right? And so by that definition, I have two angles that match in two triangles. So I have a similar triangle. Okay. So from here, I'm able to apply this process, okay? So you're like, okay, well, what information do I have? Well, I have the fact that this bottom piece is 10.5 and this one is 7. Okay? So it looks like I'm going from 10.5 to 7. Well, what number, or specifically what we call the scale factor, dictates how these two triangles are changing. Okay, well, to figure that out, you could go, okay, what is that number? This is what we call a scale factor. It's 1.5. That's how the triangles are changing. So either, here's what's going to happen. You're going to go from the small one, right? And obviously, if you're going from something small to something big, you're going to multiply by 1.5. If you're going from the big one to the small one, you're going to divide by 1.5. Okay? That's conceptually kind of easy, right? The scale factor piece, like how to find the scale factor, is maybe not the easy piece, right? But from a standpoint of like, if I'm going from big to small, the operation that does that for me is division. And if I go from small to big, I multiply. That's what multiplication does, right? So it's the only really trick is figuring out, okay, well, what is the scale factor numerically? How much bigger am I multiplying by? How much am I cutting it by, right? Is the question. Okay, does anybody have any issues with that? Remember, I found that from looking at the two side lengths that were similar or matched up side by side, right? When I drew the triangles. Okay, you don't want to match 10.5 with CB because those two side lengths aren't similar, right? They're not the corresponding side lengths. Okay, so let's, for instance, I'm going to leave this up here for a sec. Those two arrows. It's now told me, okay, in the second part here is BC, side length BC is 10 centimeters. Okay, well, where is BC is the issue, right? Which is why we went over this at the beginning of the lesson. Where is side length BC? Side length BC is right here, from B to C, right? And so we're saying side length BC is 10 centimeters. Okay, well, the question is, what is the length of our S? Our S is here, right? What is this length? It's an unknown. All right, well, we know something on the little triangle, and we want to get to the big triangle. So we could say, okay, well, if I know 10 is the side length, if I multiply by 1.5, I'm going to get my answer of the question mark, right? That's what I'm looking for, is this question mark. So you can say, okay, well, what is 10 times 1.5? I could type into my calculator, or you could know that it's just 15. So then you can say, okay, RS equals 15 centimeters. Okay, this is kind of like the two-step process where, like, in the top part, I figure out what the scale factor is. This is like one way to do this. Okay, well, I'll change it up in the bottom question here in number 2. I'll combine both those two steps, right? Part A and part B is 2 steps. I'll combine them into one line. Okay, so you can choose to do it like this question, or you can choose to do it like this. It's up to you. Okay, and I'll do it 2 separate ways. Okay, first things first though, when I read a word problem like this, I like to depict the word problems using pictures. Okay, so on a sunny day, Liam, right? Liam is standing by a tree, okay? And he casts a shadow on the ground that's 3.5 meters long, okay? And so I'm just going to draw Liam, which I've already drawn, right? And Liam stands 1.7 meters tall, right? And then he casts a shadow, which is, it's not going to do it, 3.5 meters. Okay. Then we're looking at, okay, beside Liam, or Liam standing next to a tree, right? It's a horrible tree. Right, you get the point. Okay. Stand next to the tree, and the tree, we don't know how tall it stands, but we do know how long of a shadow it casts, right? It tells us that. It says, okay, it's 18.2 meters long. Okay. So, how tall is the tree is the question. Wow. Okay, well, we could say, we could denote this anything if you wanted, X, H, whatever you want. Okay. So, this is what I mean. Okay, I'm just going to try and answer this question, right? What I have here is it looks like I have two side lengths and a contained angle, right? For my that's how I would know that these two triangles are similar, okay? And so what I'm going to do is I'm going to combine these first two steps from question 1, okay? That's what I'm going to do down here, okay? So here's what's going to happen. I'm going to say, okay, I'm going to match up side lengths first. The two that I know, 3.5 and 18.2. All right, 3.5 over 18.2. If these two triangles are similar, then I can say, okay, that has to be equal to, what's next? Well, the 1.7 over, what's the thing I'm trying to find out? X. Okay? This right here is step 1. This right here was step 2 in the other question, okay? What we're going to see here is we're just going to do some math, right? And we're going to find X just in one kind of go here, okay? So what you can do, and the other thing I want you to be aware of, I always kind of like try and make sure that information from one triangle stays in the top or bottom, doesn't matter, they just have to match, and then information from the other triangle stays in the bottom. Okay, I try to keep, they're separate. That's just my way of doing it, okay? Try to make sure that information stays on top, and then bottom for each triangle, okay? Now, what you're going to do here is just solve. Okay, so what you're going to find is you're like, I can do the math on this, right? I can type that in my calculator and get a number. That number is going to be what we did up here. We call this a scale factor, right? This is where this comes from. Okay, so you're like, okay, well, let's type that in. 3.5 divided by 18.2. All right, so we get 0.0.192, you could make it, that's just fine, is equal to 1.7 over x. Okay, you just got to solve for x here, right? Well, this one's a little trickier from the standpoint that if I multiply, which you're going to have to do, if you multiply both sides by x, you're going to get these x's cancel, right? But you still don't have x by itself over here. So you're also going to have to, I'm going to rewrite this line, you're going to have 0.192x is equal to 1.7. You're going to have to divide both sides by 0.192. This is a two-step calculation, right? Now x is going to be by itself because the 0.192's cancel, right? So all we got to do is say 1.7 divided by 0.192. So there you go. And then typically if you have a word problem, you write the little therefore statement. Therefore the tree is 8.85 meters tall. Okay? Why don't we stop there? Okay, and I can lead off this afternoon's class with this question, okay? In Minds Online there, or you guys can try this. In Minds Online, you have 2 questions there for homework. There's some similar triangles, okay? There'll be lots of practice, okay? So I'll end up giving you a formative or something around this too, okay?